Okay, so let's take a look at what we've got here so far. 27 plus a negative 43 ends up being what? Negative 16 is perfect. Negative 48 minus negative 73 is positive 25. Good. Remember, that becomes plus the opposite, so plus a positive 73. 12 times negative 10, negative 120. A positive times a negative is a negative. Over here, negative 27 minus 41. Negative 68. Wonderful. Negative 18 divided by negative 9. Positive 2. A negative divided by a negative is a positive. 152 minus a negative 97. 249. Good. Because minus a negative, remember, we subtract the opposite. It becomes plus a positive 97. Okay, so we've gone over operations with single pairs of numbers. Today we want to look at what happens when we have something like this. Looking at a problem like that, there's a lot of different ways you can approach it. I mean, you might say, well, we read from left to right, so I'm just going to do the problem from left to right. Now, don't write this down because it's going to be wrong. You'd say 8 minus 3 is 5. 5 times 2 is 10, plus 7 is 17. That would make sense, but it's not the right answer. There are a lot of other different ways you can approach this problem. Well, when we do math, if we have two people do a problem, we'd really like to have them get the same answer. So to make sure that happens with these types of problems, they define something called the order of operations. Now, a lot of people refer to the order of operations as a set of steps, and it's not really what it is. What it really is levels of priority. Higher priority things have to happen first. So our first level of priority is something called enclosing symbols. Now, a lot of us were told just parentheses for these, and parentheses is one kind of enclosing symbol, but we are going to see several others as we go through. Second is exponents. Exponents include two things: powers and roots. Third level of priority, or next lowest priority, is multiplication. Now, of course, multiplication and division are the same operation, so division goes on that list as well. And finally, the lowest level of priority is addition. And along with addition goes subtraction. So back to this problem here. We go through our levels of priority. Are there any enclosing symbols? No. Are there any exponents? No. Multiplication or division? Yes, there is. There's the 3 times 2. Now, I get asked a lot, is that 3 times 2 or is that negative 3 times 2? And the answer is yes. You can treat it either way. This is a subtraction symbol. So you can either leave it as subtraction or you can change it to plus the opposite. If I change that to plus the opposite, this problem is going to become 8 plus a negative 3 times 2 plus 7. Now it is a negative 3 times 2, but notice it's plus here now instead of subtract. We're going to go ahead, just because it's simpler for me, to leave it as minus, and then it's a positive 3 times 2. So we're going to do that multiplication first. 3 times 2 is 6. So I take out the 3 times 2 and I replace it with 6. The rest of the problem does not change. Now all I have left, no more multiplication or division, so all I have left is addition or subtraction. And there's one of each. So if there's more than one thing on the same level of priority, then I do go left to right, just like reading a book. So I'm going to do the 8 minus 6 first, which is 2. 2 plus 7 is 9. So the answer to that is 9. I'm going to have you guys try one here. Give that one a shot in your notes quick. So here again, there are no enclosing symbols. There are no exponents. There is multiplication and division. Which one do we do first? We go left to right. So the first one we see going left to right is the 8 divided by 4, which is 2. So I take out the 8 divided by 4 and I replace it with the 2. Now we still have multiplication and division here. We have multiplication. 3 times 2, which is 6. We take out the 3 times 2 and put in 6. Notice nothing else changed. Now all that we have left is addition and subtraction, so we're going to work left to right. 7 plus 2 is 9. 9 minus 6 is 3. How many of you had 3? Good. Let's take it up a step. Make this 12. Just a little bit more difficult. So looking at this one, we do have enclosing symbols. There's actually more than one enclosing symbol. So as we said before, there's more than one thing on the same level of priority, we work left to right. Going left to right, here is the first enclosing symbol, or first parentheses we run into. So now we have to ask, where is its other end? Is this one it? Nope, that one's facing the wrong way. How about this one? It's facing the right way. That goes back to this one, doesn't it? We have to go all the way down here to get to the other end. So I'm drawing that purple box around that enclosing symbol. We have to start working inside that purple box, inside that enclosing symbol. Now inside there, the order of operations still apply. Are there other enclosing symbols in there? Yes, there are. We have another parentheses right here. So now we're going to work inside that set of parentheses, or inside the green box now. In there, again, order of operations still applies. Are there any other enclosing symbols? No. Any exponents? No exponents, but there is multiplication and division, yes. So we do have the 12 divided by 3, which is 4. Nothing else changes. Be very careful, because I've found through the years it seems like more mistakes are made rewriting the rest of the problem than they are combining the numbers. So be very careful if you rewrite the rest of the problem. I tend to take some shortcuts, which I'll show you in a little bit, that I just erase and replace stuff. That's sometimes easier said than done when you're on paper. So anyway, we're still working inside this parentheses here. What do we have left to do there? Yep, 6 minus 4, which is 2. Again, we replace the 6 minus 4 with 2 and nothing else changes. Now that parentheses is down to a single number. And once it's down to a single number, I don't need the parentheses anymore, so I can take them out. But as I remove that parentheses, I see that there is that 4 in front of it. What does that 4 in front of the parentheses really mean? What's it implying? Implying multiplication. It's 4 times what's in the parentheses. So when I take out the parentheses, I have to put that multiplication symbol in there. If there's already an operation there, I don't have to worry about it. But if there isn't one, I have to put in that multiplication. Now we're done with that parentheses. It's gone. We're back out to working in the larger enclosing symbol, the larger set of parentheses. In there, are there any other enclosing symbols? No, there are not. Are there any exponents? Yes, there are. We have the 3 to the power of 2. So that's got to happen first. That is 9. These chew up a lot of paper when you have to rewrite them, don't they? Our next step now, still inside the parentheses, no more exponents. So we're going to multiply and divide. We're going to go left to right. What's our first one we're going to do? 3 times 12. There we go, which is 36. What's next? 36 divided by 9, you are correct, which is 4. And then 4 times 2 is 8. And then no more multiplication or division, is there? So it's down to addition and subtraction. So we're still within the parentheses inside that green box for now. We're going to work left to right. So 8 minus 4 is 4. What's next? 4 plus 8 goes next. Yep. And then 12 plus 1 is 13. Now again, we're down to just a single number in the parentheses, so we don't need the parentheses anymore. So I'm going to take it out. Do I have to put in multiplication here? Yes, I do, because there wasn't anything there. What's next? Yeah, there's no more enclosing symbols, no more exponents. We are down multiplication. 5 times 13, which is 65. Now we're just addition and subtraction. 3 plus 65 is 68. Minus 5 is 63. Now, if you are careful, you can enter this whole mess into your calculator in one line, and it will calculate it out correctly. You have to be very careful putting it in. Now, I'm going to say this, and I hesitate to say it because sometimes pointing it out gets people to do it. But the biggest mistake I see people make is right at the very, very beginning of this. They look at that 3 plus 5 and say, oh, I'm just going to make that 8. And then go on with that. Well, you're done before you've even started, really. Because nothing else you can do could ever bring that back to the right answer at that point. This 5, every number in here except for the first and the last one has an operation going on each side of it. The 5 here has the addition going on here, but it has multiplication here. Which one has to happen first? Multiplication. So I can't do anything with the addition on that 5 until I have multiplied this side of the 5. Okay, so looking at something like this, we have this line across here. What does that mean? It means division, yes. It's called a fraction bar, and it does mean division, but it's also an enclosing symbol. It's telling us that we have to do everything on top first. Then we have to do everything on bottom. Then we have to divide. An enclosing symbol is anything that separates part of the problem from the rest of it. So we have to do the top first. So looking at that, any other enclosing symbols? No. Exponents? No. Multiplication or division? Yes. Which one to do first? 8 times 6 is 48. What's next? 24 divided by 3 is 8. So 48 plus 8 is 56. So the top comes out to be 56. Let's do the bottom. What do we have to do first on bottom? Exponents. Left to right, we have 2 to the third. So 2 to the third is 8. What's next? 5 squared is 25. Now what's left? 4 times 8, we're going to multiply next. It's 32. And all that's left is a subtraction. 32 minus 25 is 7. So the bottom is 7. So now we do have to do the division. 56 divided by 7 is 8. I'll have you guys try one of those. See how it turns out. Try that one quick in your notes. See, some of you are still working, but we're going to talk about it a little bit. Now, you can actually enter this one in your calculator. It's a little really tricky if you want to enter it all in one step. I would recommend you just use the calculator, do the top first, use the calculator, do the bottom, and then write down the two numbers and divide them out. Let's go ahead and see what we come up with here. I'm going to do the top first. What do I do first on top there? Parentheses. I'm going to do this first one first. 6 plus 5? 11. Now I'm done with that parentheses, so I'm going to take it out in the same step. Skipping a little bit there. What's next? In the other parentheses, I have 3 times 5, which is 15. Then what? 19 minus 15 is 4. Now I'm down to just that single number in the parentheses, so I can get rid of the parentheses. Do I have to put in a multiplication there? No, there's already an operation. There's already addition there. Then what? 4 times 11 is 44. 44 plus 4 is 48. So the top of this is 48. On bottom, where do I start? Parentheses, and in there I have to exponents. 2 squared? 4. And then 7 minus 4 is 3. Now that parentheses is down to a single number again. I can get rid of it. What do I have to do? Put in the multiplication. Good. Next step. 2 times 5 is 10. And then 2 times 3 is 6. And 10 plus 6 is 16. So the bottom comes out to be 16. 48 divided by 16 is 3. How many of you had 3? Good deal. These are doing really well. When we talked about integers, we talked about absolute value a little bit. Now, absolute value is the length of the vector or distance from 0. The absolute value of negative 8, of course, is 8. It's 8 units long, 8 units from 0. Well, that absolute value symbol is also an enclosing symbol. It must be done before anything else can be. Like here, that absolute value is going to work very similar to a parentheses. We have to do whatever is in it first. So inside there, our order of operations does still apply. What has to be done in there first? The 5 times 4, which is 20, right? So now inside the absolute value, all we have left is the 9 minus 20, which is, careful, negative 11. I know what you meant. So we have what's inside that enclosing symbol down to a single number. So we can take out the enclosing symbol, just like with parentheses. The difference is with parentheses, we just take it out. With an absolute value, to remove the absolute value symbol, we actually have to do something. We have to compute the absolute value. What is the absolute value of negative 11? It's 11. Now, just like parentheses, we had this number in front with no operation, that is times. So that's 7 plus 3 times 11 plus 2. And now we're back to just what we've been doing. We multiply an x. 3 times 11 is 33. 7 plus 33 is 40. Plus 2 is 42. That's okay. Mine will probably go off at least once this semester, too. Oops, sure. Okay. Another form of enclosing symbol that we run into might look like this. That square root symbol, it's asking us to do a square root, but it can be an enclosing symbol. It can separate part of the problem from the rest. So we have to do what's inside there first again. Inside of there, what do we have to do first? The exponent. 3 squared, which is 9. What would happen next in there? 7 times 3 is 63. And then add 1 plus 63 is 64. Now we have what's inside that square root down to a single number again. Like any other enclosing symbol, when it's down to a single number, we don't need the enclosing symbol anymore. Just like the absolute value, though, when we remove the symbol, we actually have to do something. What is the square root of 64? 8. Again, the 3's in front of it with no operation, so it's 3 times. Now, technically, the square root of 64 is actually 8 or negative 8, but we're going to assume positive just to keep it simple here. Now that that's gone, again, it's back to a simple problem we know how to do. 3 times 8 is 24. And 7 plus 24 is 31. What do you guys think? Easy peasy? Better than a sharp stick in the eye? Okay, well, I am supposed to leave you guys a little time to work if you want to. The computer lab next door is open if you would like to work on some of your My Math Lab homework. We now have covered everything for My Math Lab. So your homework 1 in My Math Lab is due on Monday. If it's already done, you're free to go.